Hello. In this video, we're going to discuss a new type of application problem called a work problem. So let's start by looking at what exactly is a work problem. Work problems are problems that involve two or more people or machines working together to complete a given task. Another way to think about this is, for example, that it is the part of the task that is completed by person 1 plus the part of task completed by person 2, and what that will equal will be one complete job. So one of the things we need to take a look at is, what does it mean to complete part of a task, and how can we look at that? The part of the task completed is equal to the rate that you're working at times the time it takes you to complete the task. Now this formula might look a little bit familiar because we've talked about rate times time before, but before when we talked about it, it was equal to a distance. Now we're going to use the same kind of thinking to talk about a work problem. Now to continue to look at these, we need to really understand what is a rate of work. We define the rate of work as being if a job can be completed in T units of time, then the rate of work is going to be 1 over T job per unit of time. Okay, so let's say, for example, that you were going to clean your house, and let's say it takes you 4 hours to finish cleaning your house. Well, that would be your one complete job, would be the house is clean. At what rate are you working would be that you can do 1/4 of the house, which would be your job, in 1 hour, which would be your unit of time. So if you know the full length of time, you will always take that number and take 1 over that. So here is the key for remembering how to deal with rate of work. It is always, your rate of work is always 1 over the amount of time it takes to complete the work alone. So this is the difference that you're going to have to deal with as you're working with work problems, and it's probably easiest if we take a look at a specific example. So here's an example of a very typical work type related problem. Fred can paint an average sized house by himself in 40 hours. His partner Rebecca can paint the same sized house by herself in 35 hours. How long will it take them to paint an average-sized house together? Now, the nice thing about these problems is we can use a table like we have in the past to help us organize the information and develop the proper equation. So I'm going to use a table here that is going to involve Fred and Rebecca. And in my columns, I am going to be looking at their rate, their time, and now what I'm going to look at is the part of task. Again, this is a work problem, so we are going to be interested in the part of the task that each of them is going to complete. Now, if you think about this problem as a work problem, you want to remember that the part of the task that Fred completes plus the part of the task that Rebecca completes is going to equal some sort of a total. Now, in this particular case, the total means that you're going to have one painted house. And so that is going to represent your complete job. So let's take a look at the rate and time and part of task for Fred and Rebecca. Now remember that Fred can paint the house by himself in 40 hours. That's the total time it would take him to paint it all by himself. So remember from the previous slide that the rate of work is always 1 over that total, or in this case 1/40th. He could paint 1/40th of the house in an hour. Now we take a look at Rebecca. Now Rebecca can paint the house in 35 hours. That's again if she painted the whole house by herself. She's a little faster than Fred and can do it in 35 hours. So her rate of work is again 1 over 35, or she can do 1/35th of the house in an hour. Now, the question that's being asked here is how long will it take them to paint the house together? So what we're looking at here is time. And since they're working together, the time for each of them is going to be the same. So I'm going to let t be my variable here, and it's going to be the same for both Fred and Rebecca. Now, we've talked before about the fact that rate times time is equal to the part of task that is completed. So for Fred, that becomes 1/40th times t, or I prefer to write this as a rational expression and say it's t over 40. You'll find that working with your equation, it may be a little easier to write it that way. For Rebecca, we have 1 over 35t, or t over 35. Now, as with many of our distance problems we've done in the past, you'll notice this last column now gives us our equation in that t over 40 plus t over 35, again, the part of task each will do, is going to end up equaling 1 complete job, or 1 painted house in this manner. So we once again have a rational equation which we've worked on solving, and so to work with this equation we want to find the least common denominator and multiply both sides of the equation by that value. So if we look at the least common denominator, or multiple of 40 and 35, those numbers are a little bit larger. It might take a while to find the right one. And I believe the smallest there will be 280. So if I multiply both sides of the equation by 280 over 1, then I can simplify this equation and solve it a little bit more quickly. So 40 goes into 280 7 times, and again 7 times the t will give me 7t, plus 35 will go into 280 8 times, and again 8 times t will give me 8t. Remember to multiply both of these terms by the 280 over 1. Also, don't forget to multiply the right-hand side by 280. So 1 times 280 is 280. And now I have a very straightforward equation to solve. This becomes 15t is equal to 280. And if I divide both sides by 15, I end up with t is equal to, it's not a really nice number. If you divide this out, you will end up with 18 and 2/3 if I use the exact value, or if I approximate here, I would get 18.67. Now either one of those answers is fine with me, but remember in the end to answer the question being asked of how long will it take them to paint an average-sized house together, you want to make sure you label. So I'm going to use the exact value here because you know I like exact numbers. So it's 18 and 2/3 hour. And so there is my final answer for that particular problem.